Hello students, so we will continue with the previous chapter, that is metals and non-metals. Today we will discuss about the extraction of moderately reactive metals. The moderately reactive metals which are in the middle of the reactivity series are extracted by the reduction of their oxides with carbon, aluminium, sodium and calcium. The concentrated ores, which are present in the form of carbonates and sulfides, they are converted into metal oxides by the process of calcination and roasting. Carbonate ores are generally converted into metal oxide by the process of calcination, and sulfide ores are converted into metal oxide by the process of roasting. Now, what is calcination and roasting? That we have discussed in the previous class also, but again I will repeat it. Calcination is the process in which the carbonate ore is heated strongly in the absence of air to convert it into a metal oxide. And what is roasting? Roasting is the process in which a sulfide ore is strongly heated in the presence of air to convert it into a metal oxide. But now the question is, why there is a need to convert it into a metal oxide? It is because it is easier to obtain metals from the oxides by reduction than from the carbonates and sulfides. So the carbonates, the ores in the carbonate and the sulfide form, that is converted into oxides, and then those oxides are reduced. Now here you can see zinc sulfide, that is by the process of roasting, that is converted into zinc oxide and sulfur dioxide gas is evolved, and zinc carbonate by the process of calcination is converted into zinc oxide and carbon dioxide gas is evolved. And now this oxide, that is zinc oxide, which is obtained by the process of calcination and process of roasting, that is reduced to zinc, and carbon dioxide gas is evolved by using carbon as a reducing agent. Okay, so now here the metal oxides which is obtained by calcination or roasting of ores are converted into the free metal by using reducing agents like carbon, aluminium, sodium and calcium. Okay, so this I have told you. Now again you can see here this manganese dioxide. Okay, this manganese dioxide, when it is heated with a aluminium powder, then manganese metal is produced. So here manganese dioxide, that is reduced to manganese, and aluminium is acting as a reducing agent, which itself is getting oxidized to aluminium oxide. This all we have discussed in chapter 1 also. Okay, now the reduction of manganese dioxide with aluminium is a highly exothermic reaction, means large amount of heat is evolved during the reduction of manganese dioxide with aluminium powder, and because of which a manganese metal produced is in the molten state. Molten state means, what do you mean by molten state? Means it is in the liquid form, because the heat, it liquefies or it melts the metal. Okay, now again you can see the thermite reaction. What is thermite reaction? The reaction of the metal oxide to form metal by using aluminium powder as a reducing agent is called as the thermite reaction. The reaction of the metal oxide with aluminium powder to produce metal are highly exothermic, in which a large amount of heat is evolved. In fact, the amount of heat evolved is so large that the metals are produced in the molten state. This property of reduction by aluminium is made use in the thermite welding for joining the broken pieces of heavy iron objects like girders, railway tracks or cracked machine parts. Understood or no? Now how a mixture of iron 3 oxide and aluminium powder is ignited with a burning magnesium ribbon. Aluminium reduces iron oxide to produce iron metal with the evolution of heat, and due to the heat, iron metal is produced in the molten state. You can see here Fe2O3 plus 2Al, and here the iron 3 oxide is reduced to iron, and aluminium oxide is produced, and large amount of heat is produced. Okay, and iron metal is produced in the molten state. The molten iron is then poured between the broken iron pieces to weld them, that is to join them. Now, extraction of highly reactive metals. The highly reactive metals such as potassium, sodium, calcium, magnesium and aluminium are placed high up in the reactivity series in its upper end. So the extraction of highly reactive metal means the extraction of metals which are towards the top of the reactivity series. The oxides of highly reactive metals, that is sodium, potassium, calcium, magnesium, aluminium, they are very stable and cannot be reduced by the most common reducing agent carbon to obtain free metal, because these metals have more affinity for oxygen than carbon. So carbon is unable to remove oxygen from these metal oxides and hence cannot convert them into free metals. Thus, the highly reactive metals cannot be extracted by reducing the oxides with carbon. The highly reactive metals are extracted by the electrolytic reduction of their molten chlorides or oxides. Electrolytic reduction is brought about by passing electric current through the molten salt. Molten means the liquid salt. This process is called as electrolysis. Understood or no? So, the highly reactive metals which are placed high up in the reactivity series are extracted by the electrolysis of the molten chlorides or oxides. Okay, so students, now for the extraction of metals towards the top of the activity series, you will view one video. Okay, and also for refining of metals also you will view one video. But before that, I would like to tell you what is electrolytic refining. Okay, what do you mean, what do you understand by refining? Children, the metals prepared by the various reduction processes usually contain some impurities, so they are impure. The process of purifying impure metal is called refining of metals. Thus, refining of metals means purification of metals. The most important and most widely used method of refining impure metals is electrolytic refining. Electrolytic refining means refining by electrolysis. Many metals like copper, zinc, tin, lead, chromium, nickel, silver and gold are refined electrolytically. So students, now you can view the video of how the extract metals which are placed in the top of the activity series are extracted, and also about the refining of metals.
Extraction of metals at the top of the activity series. Do you know which metals are at the top of activity series? Potassium, sodium, calcium, magnesium and aluminium. Simple chemical reduction methods like heating with carbon, carbon monoxide etc. to reduce the ores of these metals is not feasible. The temperature required for the reduction is too high and more expensive. To make this process economical, electrolysis methods are to be adopted. The electrolysis of their aqueous solutions also is not feasible because water in the solution would be discharged at the cathode in preference to the metal ions. Now, let us see the extraction of sodium metal from sodium chloride. Consider fused NaCl as electrolyte, graphite plate as anode and steel plate as cathode. After passing electricity, fused NaCl will be dissociated into sodium ions and chloride ions. Sodium metal will be deposited at cathode and chlorine gas is liberated at anode. The deposited sodium metal is collected for various applications. Chemical reactions at electrodes. At cathode, sodium ions by gaining electrons converted to sodium metal. At anode, chloride ions by losing electrons converted to chlorine gas. Magnesium, calcium, potassium Aluminium are also extracted in the same process.
Electrolytic refining of metals. Electrolytic method is the most common method for refining of metals. In this process, an anode is made of the large pieces of impure metal while a cathode is made of the thick sheet of pure metal. Put these electrodes into copper sulfate solution, which acts as an electrolyte. Cathode connects with the negative terminal of the battery and anode connects with the positive terminal of battery. When current passes through electrolyte solution, the positive charge in the electrolyte gets attracted towards the cathode and converts into copper. As time increases, deposition of mass of copper increases on the cathode and electrode becomes thicker. As the metal ions move towards the cathode, the equal amount of ions are released by the anode in the solution. The soluble impurities goes into the solution, whereas the insoluble impurities settle down at the bottom of the anode and are known as anode mud. Thus the copper is refined by this method.
Now we come to corrosion. What do you understand by corrosion? This we have discussed also in chapter 1. Actually, corrosion is a natural process that converts a refined metal into more chemically stable forms such as oxide, hydroxide or sulfide. Or it is the gradual destruction of materials by chemical and or electrochemical reactions with their environment. Okay, how you can prevent corrosion? This we have done before also. The corrosion of the metal can be prevented by coating the surface using any one of the following methods: by applying oil, grease, paint or varnish on the surface, by coating or depositing a thin layer of any other metal which does not corrode. The surface of iron can be prevented from corrosion by depositing a thin layer of chromium, zinc or nickel on it. Similarly, brass or copper can be protected by coating it with a thin layer of tin. Okay, depositing a thin layer of zinc metal on iron object is called as galvanization. Okay, then next is by connecting metal to a more electropositive metal. Then next is by alloying. What is an alloy? Alloy is actually a homogeneous mixture of two or more metals, or a metal and a non-metal. Brass is an alloy of copper and zinc. Bronze is an alloy of copper and tin. Solder is the alloy of lead and tin. And amalgam is an alloy of mercury and any other metal. Okay, students. So this is all about corrosion, and I finished chapter 3 also, that is metals and non-metals. Okay, now we will do revision of chapter 2 of chemistry, that is how the metal carbonates and metal hydrogen carbonates, they react with hydrochloric acid, and how the zinc or the metal reacts with acid. So now we will revise these two activities, okay, by watching the video. Thank you, students.
Acids react with metal. What will happen when acids react with metals? Let's see this through an activity. We have taken dilute sulfuric acid, zinc granules and soap solution. Add dilute sulfuric acid to test tube containing zinc granules and observe. The sulfuric acid reacts with zinc and releases hydrogen gas. To test this gas, we pass it through soap solution using pipe and cork setup. On passing gas, bubbles are formed in the soap solution. Bring a burning matchstick near the surface of the soap solution. You can observe the burning of hydrogen gas with a pop sound. This indicates the presence of hydrogen gas in bubbles. Hence, when acids react with metals, it releases hydrogen gas and produces respective salts.
Carbon dioxide turns lime water, a solution of calcium hydroxide in water, milky. The change is due to the formation of insoluble calcium carbonate. Acids generate carbon dioxide from carbonates and bicarbonates. Fit a 2-hole rubber cork in a conical flask. Add a small amount of the substance to the flask. Add dilute hydrochloric acid through the funnel. Insert the other end of the glass tube into a test tube containing lime water. Observe that it turns milky. Repeat the same experiment with sodium bicarbonate.